The video you are about to see demonstrates the proper sterile techniques for use with a sterile hood. Sterile hoods are a common feature in today's laboratories. They have become an important and useful tool when working with tissue cultures and pathogens. They greatly reduce the risk of contamination to the cultures, and certain specially designed hoods can also protect scientists from coming into contact with deadly diseases. Sterile hoods are used mainly with tissue cultures and pathogens. In this video, we will demonstrate the use of sterile hoods for tissue cultures, specifically callus and root transfers, because they are non-toxic to humans and easily show proper sterile techniques for working in the hood. There are two main types of hoods used in laboratories today. They differ primarily in the direction of airflow. Thus, proper hand placement varies depending on which style of hood is being used. The principal operation of each hood is the same. Air is circulated through a HEPA filter, which filters out particles down to 0.3 microns. HEPA stands for High Efficiency Particulate Air. This filter is one of the most important components of the hood because it removes much of the airborne contamination, including dust, all cells, and most viruses. Both types of hoods also contain an ultraviolet or UV light, which kills many of the microorganisms not removed by the HEPA filter. The UV light is left on while the hood is not in use. The first type of hood we will discuss is a vertical laminar flow hood. To show the direction of air circulation inside the hood, vapors from dry ice will be released within the hood and picked up by the hood's filtering and circulating system. In the vertical laminar flow hood, the air circulates as the name implies. The air is picked up at the front and back of the work area, where it is passed through the HEPA filter and recirculated back down over the work area. The most important thing to remember when using the vertical laminar flow hood is to never let your hands pass over an open container. This blocks the flow of sterile air over the container and greatly increases the risk of contamination from microbes, which could drop from your skin. As for the second type of hood, the horizontal laminar flow hood, the air also flows as the name implies. It flows horizontally, blowing from the back of the work area to the front, where air is picked up and passed through the HEPA filter and blown over the work area again. In this case, your hands must never pass behind any open container because this will block the flow of sterile air and greatly increase the risk of contamination by blowing microbes off your skin and into sterile vessels. There are several safety issues that must be addressed before the demonstration can begin. The most important safety issue is the use of an open flame and 95% ethanol. If the container of 95% ethanol catches fire, never attempt to blow it out or remove the container from the hood. Simply put the cover back on the container to extinguish the flame. Use caution when handling the scalpel because it is very sharp. Also, be sure when you flame an instrument that you let the flame extinguish. Allow enough time for the instrument to cool. Otherwise, you could not only burn yourself, but you might also kill the tissue. Now we are ready to prepare the hood and our instruments for use. First, turn off the UV light because if you do not, it can burn you just like the UV rays from the sun. Begin by assembling the instruments and supplies outside the hood the same way they will be used in the hood. This allows us to work more quickly and efficiently while we are working in the hood. This also helps to reduce the risk of contamination. The supplies that will be used in this demonstration are a scalpel to dissect the callus and roots, forceps which are used to hold and move pieces of the callus and roots, 70% ethanol which is used to disinfect hands, equipment, supplies, and the work area inside the hood, a Bunsen burner or alcohol lamp which is used to flame sterilize the scalpel and forceps and to flame the opening of test tubes and flasks, tobacco callus which is one of the plant tissues being cultured, beetroots which will also be cultured, 95% ethanol which is used to sterilize the scalpel and forceps, a sterile empty petri dish which is used to hold the tobacco callus during dissection, deep petri dishes containing solid tobacco initiation media, large test tubes containing solid tobacco initiation media, a test tube rack to hold the test tubes, an Erlenmeyer flask containing liquid growth media for the beetroot cultures, parafilm to seal containers once the tissue is added, an igniter or matches to light the burner.